In this video, we're going to look at just another example of finding partial derivatives. So in this particular one, we're given a function of three variables, f of x, y, z equals xy squared e to the negative xz, and we're asked to find the partials with respect to all the first partials. Well, since it's a function of three variables, we've got three first partials that we can find with respect to x, with respect to y, and with respect to z. So notice that if we take the derivative with respect to x, I really have two functions of x, right? I've got an x here and an e to the minus xz here. So to do this derivative, we'll have to use a product rule. Derivative of x is 1. The second function is just this whole piece, so that's where the y squared e to the negative xz comes from. Then plus the first times the derivative of the second. Well, again, the y squared is just a constant, so it can just go along here for the ride. Here, my second function is e to the negative xz. Derivative of e to a power is e to the power. Then times the derivative of the power. Well, again, the z is a constant here, so we're just differentiating the x, and that's where the minus z comes from. And then we can pretty it up and factor out a y squared and e to the minus xz, and that's where we get the y squared e to the minus xz times a 1 minus xz. All right, when we differentiate with respect to y and with respect to z now, notice that we don't have a product rule anymore that we have to worry about. Because I only have one thing that has a y in it, I only have one thing that has a z in it. So when we differentiate here, the x and the e to the minus xz are just constants. Derivative of the y squared is 2y. So put it all together, we get 2xy e to the minus xz. Likewise, when we differentiate again with respect to z, this is the only part that has a z in it, so the xy squared is a constant, so it will have the constant times the derivative. And like we had before, derivative of e to a power is just e to the power, but this time we're differentiating the z, which is where the minus x comes from, because the derivative of z would just be 1, and then simplify, we'll get negative x squared y squared e to the minus xz.